In this video, we are going to solve the last 5 questions of exercise 13.3 of class 10th, chapter number 13, which is surface area and volume. And you can find the link for the remaining questions in the description box. Hello my awesome students, welcome back to my channel Akshar. I am Nena and I make videos related to NCERT solutions for classes 9 to 12. So let's start solving our very first question of this video, which is question number 5 of class 10 and exercise 13.3. The question says that a container shaped like a right circular cylinder having, so there is a container which is in the shape of a cylinder and having diameter 12 centimeter. The diameter of this figure is given to us equal to 12 centimeter and the height is 15 centimeter is full of ice cream. Complete ice cream is filled into it. Now what they are doing, the ice cream is to be filled into the cones. They are filling this ice cream into different number of cones and the height of the cone is given to us equal to 12 centimeter and the diameter is given to us equal to 6 centimeter, also having a hemispherical shape at the top. So cones are not like this, cones are inverted, cones are there like this. So there is a hemispherical shape on the top and height of the cone is 12 centimeter and the diameter is 6 centimeter. So while doing our calculation, we have to consider two figures. One is cone and one is the hemispherical shape. Then find the number of the cones which can be filled with the ice cream. So this is a hemispherical shape. Find the number of the cones which can be filled with the ice cream. So now what they are doing, they are transferring ice cream from the cylindrical shape to the conical shape. So what will be there, that the volume of this cylinder will be equal to the volume of this cylinder will be equal to the sum of the volume of all of this cone. Earlier, when there was only one shape conversion, means one cylinder was converting to one cone, then we were taking that volume of cylinder is equal to the volume of cone. But now more than one cones are being generated, so we will do addition of all the cones. So how I can write down that the volume of cylinder is equal to, if I will do addition of all the volumes of the cones, because dimensions are equal, so I will get what, n into volume of cones. Suppose there are only two cones and I have to do addition of two cones of the volumes, volume of cone 1 plus volume of cone 2. So dimensions are equal, so I can write it down as 2 into volume of the cone. So now I do not know how much cones are there. So if I am doing addition of third cone also, so what I will write down? I will write down 3 into volume of the cone. So now I do not know how much volumes of the cone I am adding. So I will use simply n into volume of the cones. So volume of cylinder is given by what? Volume of cylinder is given by pi r square h, and this will be what? And here also I have told you one more thing, that you have to take the volume of the hemispherical top also, right? So put the formula. Volume of the cone is what? Volume of the cone is 1 by 3 pi r square h plus the volume of hemispherical is what? 2 by 3 pi r cube. So now to differentiate between what is radius of cylinder and height of cylinder, we will use r1 and h1, and for this we will use r2. Okay, so now from this side, which part you can take out common? You can take out pi and r square and 1 by 3 as common. So pi by 3 into r2 square is common, and inside the bracket 1 into pi and r2 square by 3 is common outside. Inside the bracket it will be h2 plus 2 into r2. Because r2 square is common, so power is left what? 2 is outside, so only 1 is left inside. So I will put it as r2. So pi and pi 6 centimeter. So radius will be what? Radius will be 3. Height of the cylinder is 12 centimeter. N into 1 by 3 into R2 square is what? R2 is my radius of the cone. R1 is what? Radius of the cylinder is given to, diameter of the cylinder is given to us 12 centimeters. So radius will be 6 square. Height of cylinder is 15. N into 1 by 3 into diameter is 6. So 6 by 2 will be 3 square into height is what? Height is 12 centimeter into R2 is 3 centimeter. When you will solve this value and finally cancel out what is getting cancelled out, so you will get n is equal to 10. Means we have find out that there are 10 cones in which ice cream is being transferred. Okay. Moving to question number 6. Question number 6 is that again they are asking about the quantity. How many silver coins of 1.75 centimeter in diameter and thickness 2.22 must be melted to form a cuboid of this dimension? Okay. So silver coins are there. So silver coins are generally in the shape of what? Which you have seen in your life. It is in the shape of a cylinder and they are being converted into a shape of a cuboid. Number of cylinders are being converted in the shape of a cuboid. So what we will do? We will write down that n into volume of cylinder is equal to volume of the cuboid, because one shape is being converted to another shape. So simply we will use n into volume of cylinder is equal to volume of the cuboid. So write down the damn formulas. Formulas are what? N into pi r square h. Volume of cuboid is what? Volume of cuboid is L into B into H. So now differentiate it with R1, R2 and H1 and H2. So N into pi is what? Pi is my 22 by 7. Radius dimensions are given. What diameter is given to us for this is 1.75. So put the value 1.75 by 2 whole square into this 2 millimeter thickness is given to us, because all the remaining dimensions are in centimeter. So we have to convert this 2 millimeter into centimeter. Length is 5.5 into breadth is 10 and height is 3.5 centimeter. So again, after doing simplification, you will get number of coins is equal to 400. So the main part is that you have to understand the statement that n number of coins are there which are in the shape of a cylinder and they are being converted to a cuboid. So we have equated the volume of cylinder with the volume of the cuboid. Okay. So moving to question number 7. Question number 7 says that a cylindrical bucket 32 centimeter high, 32 centimeter height and with a radius of 18 centimeter. This radius is given to us 18 centimeter is filled with the sand. Now this bucket is emptied on the ground and a conical heap of the sand is formed. This conical heap of the sand they are forming. If the height of the conical heap is 24 centimeter, this is given to us equal to 24 centimeter, then we have to find the radius and the slant height of the heap. So we have to find out what? We have to find out this radius and we have to find out this slant height. So to find out this, what we will do? We will do the same process which we are doing till now, that the volume of the cylinder is equal to the volume of the cone. So volume of cylinder is what? Volume of cylinder is pi r square h and the volume of cone is 1 by 3 pi r square h. So write down this r1, this is as h1, this is as r2 and this is as h2. Pi and pi will get cancelled out. R1 is what? R1 is my 18 centimeter, 18 square into H1 is the height of the cylinder which is equal to 32. Now 1 by 3 into R2. R2 is, we have to find out the value of R2. and into H2. H2 is what? H2 is my 24. So once you are going to solve this and solve the under root value, so you will get your value as R2 is equal to 36 centimeter. Okay, one part is done. We have to find out this radius of the cone. Second part is we have to find out the slant height of the cone, and slant height, to find out slant height, what is the formula? L is equal to under root of h square plus r square. H is what? H is 24 square plus radius is 36 square. So solve this value and do the under root. So you will get L is equal to, okay. Number 8 is little bit different, so see it very carefully. What does the statement says? Water in a canal 6 meter wide and 1.5 meter deep. So water is in the canal. So canal is in the shape of what? So canal is suppose in the shape of a cuboid. So dimensions are given to us 6 meter and 1.5 meters. So 6 into 1.5 meter dimensions are given to us. In this, the water is flowing with a speed of 10 km per hour. So in this, the water is flowing at the speed of 10 km per hour. How much area will it irrigate in 30 minutes? So we have to find out the area for the 30 minutes. Then if 8 centimeter of standing water is needed. For this 8 centimeter of standing water is needed. So we know that 10 km per hour means in 1 hour it is irrigating an area of 10 km. So we have to find out the area irrigated by the canal in 30 minutes. Okay, so let's first find out that how much is the volume of the water in 30 minutes. To find out that, we have to find out the volume of the water in 1 minute. So volume of the water for the cuboid is given by what? Length into breadth into height. So this is given to us 6 into 1.5 into height is what? Height is this water, because in 1 hour this much height of water will be filled. This water is being filled into it. So in 1 hour this much of the height is filled. So all the dimensions are in meter. So I am converting this also in meters divided by hour. This is in 1 hour. So if I have to convert it to minutes, so what I will do, I will divide it by 60, right? So now I have to find out the volume of the water in 30 minutes. So by using a unitary method, how I can find out? This into 10,000 by 60 into 30. So I will get what? 30 into, after solving this complete calculation, I will get 30 into 1500, which is equal to 4500 meter cube, right? So now we have to find out the volume which is being irrigated is given by, so suppose volume of the how much water it will flow, volume of the water from canal is equal to the volume of the area irrigated in 30 minutes. So how much water it will release in 30 minutes, the same area will be irrigated in 30 minutes. So volume of this we have find out 4500. So now let us suppose that volume is what? Volume is given by area into the height and divided by area into the height. Okay, so area we do not know, area we have to find out, and height is what? How it is given to us, equal to 8 centimeter of standing water. Height is 8 centimeter. So to convert it into meter, I am dividing it with the 100. So after solving this value, so area will be equal to 562,500 meter. Understood? The statement says that a farmer connects a pipe of internal diameter 20 centimeter from a canal. From a canal, it is connecting a pipe and diameter of this is 20 centimeter into a cylindrical tank. Into a cylindrical tank it is being connected, and which is 10 meter in diameter and 2 meter deep. So this is 2 meter. If the water flows from the pipe at the rate of 3 kilometer per hour, in how much time will this tank be filled? I have to find out the time in which this tank be filled. So to find out the tank time, what I need first, I need that what is the volume of the tank. According to that, it will take the time. If the volume is 2 meter cube, then it will take some less time. If the volume is 4 meter cube, then it will take some more time. So to find out the time first, I need the volume of the cylinder. Okay, so how to find out the volume of the cylinder? So volume of the cylinder, how I can know that how much is the water being filled from the pipe, the same will be the volume of the cylinder, right? So let's first find out that the volume of the water flows, I don't know how much time it is taking. So let us, volume of the water flows in 1 minute. So let us first find out the volume of the water flows in 1 minute, and let us imagine that it takes approx t minutes. Okay, so volume of the water flows in 1 minute will be equal to what? It will be equal to r square. H by r is what? R is my 20 centimeter. So let's convert all the dimensions in the form of a meters. The diameter is 20, so my radius will be 20 by 2 whole square into the height. Height is what? Height is my this 3 kilometer per hour, because water is being flowing at the rate of 3 kilometer per hour. So convert all the dimensions into the same unit. Kilometer will be converted to meter and hours will be converted to minutes. So this is the amount of the water which is being flowed from this pipe to the cylinder in 1 minute. So I don't know how much water is flowing, how much time it is taking. So let us imagine that it is taking t minutes to completely fill this tank. So total volume will be what? T into pi into 30 by 1000 into 2 into 3 into 1000 by 60. Okay. So this is the volume of the water being flowed from this cylindrical pipe, and this is equal to what? This is equal to the volume of the cylinder, volume of the big cylinder, volume of the cylindrical tank. I can say the volume of the cylindrical tank in t minutes. In t minutes, the cylindrical tank will be completely filled. Again, the pi r square h, pi will be remain same. Radius is what? Diameter is 10, so radius will be 5 square into height is what? Height is my 2, so my values will be 5 square is 50, 50 into 2, it will be 50 pi. Okay. So now I have told you both the values are equal, because the water which is being flowed from this pipe is equal to the water being filled in this cylindrical tank. So when you are going to equate both the volumes, then you will get this value. Now solve whatever is getting cancelled out. Let's cancel it out and then expand the remaining part. 20 by 100 into 2 into 20 by 100 into 2 into 3 into 1000 divided by 60 is equal to 50. So double zero and zeros will get cancelled out. This 0 and 0 will get cancelled out. So let's just cancel out what is getting cancelled. 0 and 0 and this 0 and 0. 2 and 2 will get cancelled out. Now this 2 into 3 will become 6 and this will get cancelled out with this 6. So I am left with what? I am left in the denominator with 2. 1 by 2 is equal to 50. So T will be equal to 100 minutes. Okay, 50 into 2 will become 100. So I will get my answer as 100 minutes.